Hi, pre-algebra 9.3, the Pythagorean Theorem. Some of you have seen it before and some of you haven't. So it deals with right triangles. Now you know a right triangle when you see this little square in the corner because that means 90 degrees. And they use a little square because 90 degrees is what the corner of squares are, okay? Now there is some vocabulary. These two shorter sides that make up the right angle are called legs, okay? Legs are just the two shorter sides. Now the side across from that 90-degree angle is called the hypotenuse. It's always the longest side because it's across from the biggest angle. Now, something you might have thought about, because I know that all of you know that a triangle adds up to 180 degrees. We talked about that in class. But if this is 90, it's the biggest angle because these two are acute. They have 90 degrees total to make up both of those angles. So this is always going to be your biggest angle. These two will add up to 90. The two acute angles will add up to 90. It makes sense. 180 minus 90 leaves 90 left, okay? Now, the Pythagorean Theorem says that if this is side A, and this is side B, and this is side C, then A squared plus B squared equals C squared, okay? Now, probably the most common right triangle, and if I could draw one kind of to scale, is your 3, 4, 5 right triangle, okay? Because 3 squared plus 4 squared equals 5 squared. 3 squared is 9 plus 16 equals 25, and that is true. 9 plus 16 does equal 25, okay? Now, example 1 in the book, they're talking about a bridge, and it uses really big numbers, and you would probably do that with a calculator, okay? If you look at example 2 is finding the length of a leg, and they tell you that you've got this triangle that looks kind of like this, okay? And this side is 10, this side is 12, this is a leg, they call it A, okay? And you want to find A. So 10 squared, A squared plus 10 squared equals 12 squared. Now you know 10 squared and you know 12 squared, so that's no biggie. A squared plus 100 equals 144. Now, since I want to find A squared, I have to subtract 100 from both sides. So A squared is going to equal 44. Okay? Now, because we've learned how to simplify radicals. Now, remember, a square root will get rid of that square. So if I do the square root of A squared, I'm going to get A. Now, we simplified radicals, so I want to think of that as 4 times 11, because 4 I can do. Okay, so the length of my other leg is 2 times the square root of 11. Okay, let's look at the checkpoints. The checkpoints, I'm not going to draw the pictures. They tell me A. So 20 squared, they don't tell me B, equals 25 squared. Now, one of the things, I got so frustrated because you know what, I hate to use a calculator if I don't have to. So I got this is the table in the back of your book. I copied it because you know what, all the answers are on here. 20 squared, here's 20, squared is 100. 25 squared is 625. So I got all my numbers. 400 plus B squared equals 625. Then I don't have to use a calculator. Subtract 400, B squared equals 225, okay? And I know I can look at this table too and see here's 225. That means the square root is 15. b equals 15. That's checkpoint number 1. Checkpoint number 2. A is 10, b is 24. That means I don't have to do subtraction, I can just do addition. A squared plus b squared equals c squared. Again, I can use my table for 24. 100, 24 is 576 equals c squared. So 676 equals c squared. And I'm going to look on there. Ooh, 676 is 26 squared. So c equals 26. Isn't that sneaky how you can use that table? Makes so much sense. All right, let's look at number 3. Checkpoint number 3, they don't tell you a. So a squared, b is 12. And that's going to equal c squared, which is 14 squared. Okay, we know 12 squared. A squared plus 144. 14, if I look at my table, is 196. And when I subtract, I get that a squared equals 52. Okay? Do the square root of both sides. I didn't put that on that one. Do the square root of both sides, and a equals, 52 is not a perfect square. But I do know that it's 4 times 13. I can do the square root of 4, so it's 2 times the square root of 13. Now, the converse says that because a squared plus b squared equals c squared, if that's true, it's a right triangle, okay? So I could also know it's a right triangle if a squared plus b squared equals c squared. And so they give you a couple of examples, and it's just kind of doing the same thing. All right, I hope that helps you understand the Pythagorean theorem a little bit better. Bye.